Right. Okay, so today again going to learn the Cisco networking. I'm just trying to go through the modules just to understand the things. I haven't ever done this before, so it's also my first time. Okay, now move on. We have domain name system. Right. I don't know what it's, but you can look at this too. There are other applications specific. Mm-hmm. Okay, so in this we have the user types and FQDN into browser application address field. Okay, type this here. And then can type the FQDN domain name browser and then a DNS domain server system server is sent to this designated server from the client computer. After that, the DNS matches with this IP address. So we type the FQDN in the application address sign and then is sent to the DNS server to search for the designated DNS. DNS queries into for the client. For the client computer. The client computer is match it with the network with this IP address. Okay. And then the DNS query response is sent back to the client with IP address for the FQDN. DNS query response and finally uses the IP address to make the request of the server uses. Query uses this IP to make the request. Okay. Message format we have 4, which is A and N devices. IPv4 quadra A with N device IPv6. And X for mail exchange and S for authoritative name server. Okay. All records. First look at it all records. So if it's unable to resolve other servers okay. Requesting Windows pieces to store previously resolved names in memory, ipconfig and display DNS command all cached DNS entries. For the name server answer, which called resource records answering authority, which is pointing toward an additional information. DNS hierarchy. We have org.com, .org, .au.co, different top level. Uses a hierarchical DNS protocol, hierarchical to name solution uses providing from the hierarchy is responsible for managing TAM to IP mappings. It's scalable because whenever solution is spread across multiple servers. The domains of the country of origin. Okay, .vn is also something like that, right? We have .net, .edu, top level TLD, c.co, .au, .com, .edu, .net, and we have this. What you done? With the star boy. Alright, we have an S lookup command is used. The default in a server figure host is displayed. If host or domain can be entered at an S lookup prompt. Okay, this is the ns lookup command, default server address, and then server address name aliases. Okay, syntax check from the Windows prompt, enter the ns lookup to begin. Okay, command prompt, just check for ns lookup, right? The link router, okay. Can I type this here? Yeah, also we can type this here as well. I wanna see you again. From where we began. About it when we see you again. When we see you again. Alright. Check your understanding. I resolve. Okay, this one's AAA. Alright. Again, that receives a request from array. Solution is not within you. Send the file message. Now amplified, right? Look for another. Now we forward request. Yeah, it will look in other zone, different zone. So that is false, which is displayed by lookup utility or cached. No IP address. Configure default. Oh, maybe it is the configure default. Yeah, the default configure default. That's right. Next, we have types authoritative is NS name server. Okay, it's kind of easy for this. Lab observing the website. Okay, require observing ping web icon.com. Control C. Just to see what is gonna happen here. Okay, let's have things here. Addresses, the aliases, no response from the server. Oh, nothing is working. Maybe I do not do this at the moment. I know what the ping will do. It will show the connection. So yeah, it's not really the fix. Okay, now next we have the configuration domain host. Domain host configuration protocol automates the assignment of IPv4 address, netmask, gateways, other IPv4 networking parameters. All right, we have here. This is like the small the small basic map for the DHCP protocols. When you were of this with the switch, the router, the DHCP clients do a slow call and to other network server router HCP server here ASP1, ASP2, ASP3. Well, The HCP server for small home visits, home and small business one as well. I want you to know. Goes to you. Let me sure we have the HCP client, router, HCP server, similar services for IPv6 clients. Does not provide default gateway address. The router advertisement message of the router. Oh, there's no default gateway for IPv6. Okay.
DHCP, or Dynamic Host Configuration Protocol, is a service that enables devices to automatically receive their IP address and other addressing information from a DHCP server. Similar 192.168.1. Topology, you can see that our home router has the IPv4 address 192.168.1.1 and has also been enabled as a DHCP server. Instead of a single port to connect our local devices, most home routers include an embedded Ethernet switch. Client devices such as PC1 and PC2 will typically receive their IPv4 addressing information from a DHCP server. PC2 has already received its addressing information using DHCP. By automatically assigning addressing information, DHCP eliminates possible problems due to manual configuration errors. However, some devices, such as a printer or a server, will most likely have their IPv4 addressing information configured manually. This is to ensure that these devices have a specific IPv4 address. A DHCP server can be a separate computer, but in the case of most home networks, the local home router will act as a DHCP server. So in our scenario, we will be using the home router as our DHCP server. The home router has been configured as a DHCP server to provide addressing information for the clients, including the pool or scope of IPv4 addresses, typically private IPv4 addresses. Each DHCP client
Tôi
will
mới
receive
vô
a
mà
unique
không coi tôi
IPv4
không được.
address from this pool. The DHCP server keeps
Tôi
track
mới vô, ông vô trước một dáng đi. DHCP, we have DHCP discover, offer, request, and acknowledgement. Next, receive. Do you want to study? Mom. Hello. Sao Quang? Alo. Tôi mới vô trận mới 2.2. Vô đi ông vô trước trận đi. Tôi dạo này đang test bài, tôi đánh thắng thua liên tục luôn để test coi bài nào mạnh. Ai về tôi thấy bài nào cũng lỏ chứ tôi chơi cái gì cũng lỏ. The HTTP clients initiate the HTTP process by sending request to the HTTP server. Now it is the DHCP discover. It should be the HTTP discover. Okay, let's describe automates the assignment of IP address, gateway, other IPv4 networking parameters. Okay. ARP automates the process for discovering, ARP, which is address resolution protocols, is for MAC addresses. The main system is for discovering IP address, as we have seen before. This one, and then NAT, name name address. Translating is translation of private and public IP addresses. Correct order: discover first. The client will discover for ask all of the server found for some DHCP server, and then it will send the request. Offer, and then we ask for request, and it is an acknowledgement. Okay. Next, finally, IP addressing services, which is we do to review all the things we learned in the module 35, which network service automatically assigns IP addresses to devices on the network. Assign IP address automatically. Okay, sure. We have DHCP. Telnet is for like SSH to work on the remote server. DNS is gonna take us to find the IP. Oh, wait a minute. Where is it? Gosh. Wait a minute. Show feedback. Yeah, the HCP auto DNS discovering. This one is automated assignment of the IP. Okay, so automatically assigns the HCP. Just put attempting to list address. A host VC had just booked it and is attempting to link address through which would the client broadcast. So it is discover and request. Next, host is trying to resolve the name internal access code to an IP address received by a root DNS server, which server will include a response for further resolution. Okay. Oh, I do not know what it's gonna do. So we have this one. Just look at this. So maybe D is correct, right? On .com now because I've asked for this. So maybe D. Or at least it should be cisco.com. Maybe D, web server D, right? Which server? Maybe this is correct. I think it's true about the HCP. Okay. All right, we have if the client receives several of messages from this send a unicast, now is send a broadcast. Wait for lease expiration, no. Configure to use broadcast to identify. Yeah, this was correct. Absolutely. Next, we have we want send to that is offered by the HC. Send to after offer, it is the broadcast request. Okay. Which translate into a network address is domain name system. DNS MX record. O is mail exchange. So it could be like the IP address for domain name map to this. Is it? It looks like this is the answer. Okay. For to make exchange servers, a technician is adding an APC to LAN and then unpacking the component and making all the connection. That's the PC. After OS loads, open the browser, verify it can reach the internet with no additional configuration. Doesn't require addition now. Use DNS. I think this one could be the answer. Is malfunctioning if using ping to web server, we cannot ping the web server host name. If a user can ping a web server but not ping the web server host name, can ping the web server but cannot ping the web server host name. Maybe it could be this. No, web server host. Okay, we have question number 10, which used to type is that IP address, so it is DNS. I will change this code to looking for address, IP address. Okay. Tag if it does not have entry, so for requested size. No. Okay. Oh, almost. Good. DHCP, okay, is used to provide the domain name resolution is the DNS, and automatically configure IP information is DHCP. Telnet is to remotely accessing a session of a switch or a router, trace route to the terminal path text as it traverses the network. Okay, this one is okay. This one not okay, right? Root DNS only requires for top level domains. So root top level like .com, .org, leave a host and request also from root DNS. The root server would refer the client to the server responsible for the .com domain. This would refer the client to the DNS of Cisco. But only the DNS server is authoritative for the domain. We return them. What web community related solution? Oh, so actually, what is the answer of this? What when we will so the root is gonna be for the .com, like .com.org. Recourse for this. There's a root DNS for the domain. The root would refer them to the server responsible for the .com domain. So it is A, right? It would refer to this. The DNS server for the .com domain. All right, this one correct. Okay, MX or email exchange messages. Okay. The PC was pre-configured to use the HCP. All right. Next, transport layer. Last we need to go through all of this. Transport of data, transportation. The main goals. Okay, application layer. Program generated data must be strength between source and destination. Yeah, it will be responsible with logical communications on different hosts. If this layer moves data between application on devices in the network. Okay. We have transmission control protocol and user datagram protocol, which are UDP and TCP, transmission control, and the user datagram. All right, checking individual conversations. And just earlier, each set of data flowing between the source application and the destination, because none as a conversation being tracked separately. Okay, to maintain this. So far so good. As is illustrated in the figure, a host may have multiple applications across the network simultaneously, have a limitation on the amount of data that can be included in a single packet. Okay. Into manageable pieces, we have email, streaming video, online video, instant messaging, multiple web pages. And then it also segmenting data and reassembling segments. Okay, to divide application into prioritized blocks on the transport layer protocol used, called either segments or datagrams. Okay, divide the data into smaller block segments. Datagram used to manage and transport. Add the information, which is reassemble, identifying the applications. Okay, the target called port number, and then conversation multiplexing. Sending some types of data across the network is going to consume all the available bandwidth. This will prevent other communication from occurring at the same time, will make error recovery and remission of data damage difficult. Okay. So these are the responsibilities of transport layer. Okay. Next, we have protocols which are TCP and UDP. Go on to this. Application about FTP for file transferring. This one is gonna work very well. Okay, mail, EML, DNS domain system, and FTP, and then we have transmission control, user datagram, which this is IP address, identification, and then local area network and wired and area network with network access. Application transport network, internet, and network access. We have TCP. with the structure, addressing, and routing of packets. Okay, IP is not responsible for guaranteeing delivery. Okay, then we have the IP is gonna be in layer 3 of the OSI model. Into segments, number, and checklists in specific host from a specific application, acknowledge the received data, retransmit and acknowledge data after a certain amount of time, sequence data that might have wrong order, see an efficient rate that is acceptable for the receiver. Okay, let's see how it's working, right? We want to send data of word to this router, to the router, to switch and move to this. All right. Then it will send back us. Okay. Was only that thing, I think so. UDP is simpler transport layer protocol. Okay. It is simpler. Why? Why is it to be simpler? It does not provide reliability and flow control, so it means it requires fewer header fields. You do not have to manage reliability and flow control. Also can be processed faster, but not really reliable. Yes. Okay. Appropriate application with very little overhead and data checking. Okay, very little overhead and data checking. Connectionless protocol. Provide reliability, flow control, established connection. Does not check information sent and received to the client server. Stateless protocol, connectionless protocol. Best effort delivery protocol. No acknowledgement. Okay, placing regular and then register letter in the mail, and then the sender is not aware of the availability of the receiver to receive the letter. Okay. Oh, so we will not be not checked if it is working or not. Okay. The right for the right application. So used by request and reply application, real-time video usually use UDP, but also use TCP or both. You must choose which is appropriate based on the requirements. Video may be sent over TCP or UDP. Application streams stored audio and video typically used TCP. Perform buffering, bandwidth dropping, congestion control. User experience. Application streams use the so they cannot support the bandwidth needed to watch an on-demand movie. Pauses the playback. During the pause, you may see a buffering. Okay. So we have UDP and telephone domain name resolution. All right. And for the TCP, we have reliable, acknowledged data, resends, lost data, delivers data in sequence order. While acknowledgements delivered as it arrives, it does not resend lost data. Okay, check understanding. All right, it's kind of long. So, we'll move on to number 29, number 32 as well. Okay, but first move on all of this. Responsible for temporary section to the source. Temporary, so it is. Okay, wait a minute. Just wait me for a few moments. All right, we have the question is establishing a contemporary transport layer. The physical is like the media we used. The network is trained how we can the best way to transfer the media network through the media. The data link it likes fighting for the MAC address and the network for the IP address. Okay, we have application is what we use to present on how it interacts with us. Submit, that's right. Okay, good. Our transport layer responsibility, conversation multiplexing. Segmenting it divided into small sized blocks and reassembling with the new headers. Identifying frames is what we used in the layer 2, which is data link and identifying routing information now. So it's checking individual conversations. It's true, TCP has fewer fields. No, UDP has fewer fields. TCP is also slower. It's best effective delivery. UDP is not provides reliability. TCP does it. Would be used for VoIP, which is for VoIP is for UDP. Okay, TCP overview. Now move on to this TCP overview. What is here? Scroll down to begin. TCP features. Wow, okay, there are 4, 1, 2, 3, 4, right? 4 things. It is called establishes a session, connection oriented. Okay, let's read this. It's reliable. Yeah, reliable, which is really neat. We can resense the lost data. Same order, okay? Neat and so. Numbering sequencing the segments ensures segments are reassembled to the proper order. And then hosts have limited resources, supports the flow control of a text. It's the same, reduce the rate of data flow, then the TCP, okay. Supports the flow control, reliable, set the order and establishes a session. Okay. TCP header with this. All right, we have source port, destination port, sequence number. We have acknowledgement number, have the length reserved to control this. Window, checksum, urgent options. Okay. We're not going through all of those things, but try to figure out which is here. A source port, the 16-bit we used to identify the source, by port number. Source application, destination application, kind of like the same things, right? Not really difficult to understand the concept of this. Okay, we have the destination sequence number and 32-bit used for data reassembly purposes. We have acknowledgement number, indicate that it has been received and the next byte expected from source. And data has been received and the next byte expected from source. Okay. A 4-bit field, known as the data offset, length. Length of data segment header. 6-bit revert reset, future use. Okay. Control bits include be coast flags, which indicates purpose and function. Okay. Window size, we have this, which are used to indicate the number of bytes that can be accepted at one time. Okay, this checksum is for checking. Checksum is for checking. Okay. We have urgent is contain data is urgent. Okay, application to use TCP. We have FTP, SMTP, SSH, HTTP use the TCP. All right. Which simple ensures reliable same order is TCP for sure because we are learning TCP right now. It contains 4 fields of 8 by header. in this 4 fields and 10 by header is gonna be 8 by I suggest 10 fields and 20 by header. All right, 10 fields in 20 by header. Okay, so far so good. Applications. Once again, the applications. All right. So also we know that maybe all of this used have FTP as well. But the application I should choose this, right? FTP. Oh, okay. HTTP and FTP. Oh, but on the VoIP, VoIP, we can use both. All right. Doesn't matter because we have seen it. HTTP and FTP also with the SMTP and SSH. We use this. All right. Okay, UDP overview. Like, there's really nothing really considered difficult because it's like assembling source port, destination port, LAN checksum. All right. We have source port, which is identify the source application, and the destination port, which is used to identify the destination application by port number length of the UDP diagram. We have checksum is for checking the errors. Okay, and the UDP, almost used UDP. You can see those things here. They are SNMPT, FTP, VoIP, video conferencing. Chứ không ơi, tôi sắp xong rồi 6.3 rồi. Còn thằng này tôi giải quyết đạp xong thằng này là xong rồi. Tôi mạnh quá rồi ông ơi. Tôi nổ hũ 3 con 6 tiền rồi. 3 con 6 tiền luôn rồi. Bố thiên hạ rồi. Cái form gia đình rác phải luôn á. Thề. Tôi thề với ông là cái form gia đình rác thiệt luôn đấy. Kiểu nó rác từ đầu tới cuối luôn. Đó, còn cái ấn gia đình nữa chứ phải không thì giờ này mà còn ấn gia đình nữa lại luôn. Đúng là cấp 10 có khác, RON 6 tiền đã ghê, đã tay thiệt chứ. Cấp 10 2,2% RON được 2 con 6 tiền 2 sao, một con 6 tiền 1 sao. RON đã cái tay thiệt chứ trời. Đó. Dán tên cuối nào không ơi, sắp xong rồi. Nó không có tự nhiên, đừng có áp lực. Tôi học tôi hay nói vậy thôi chứ không có vấn đề gì đâu ông ơi. Better off all by myself, though I'm feeling kinda empty without somebody else on caring. Yeah. The cell phone, oh, you don't know how it feels to be alone, oh, baby. Oh, I make you know, I make you know. Oh. Ok, xong rồi nào. Tôi đang test bài điểm cho nên tụt rank liên tục luôn. Thà tôi tụt như tụt quần vậy. Giờ elo của tôi top 1 cộng 30 điểm. Chết mẹ, tụt quá. Top 1 30 điểm ông nghĩ đi. Đẩy xã hội. 4 fields in 8 byte header and TCP will be 10 fields and 20 byte header. 4 fields in 8 byte and one honor is 20 fields in 20 bytes. Use UDP, HTTP and FTP were used both. TFTP also used, not ICMP. Oh, TFTP. Oh, all right. ICMP is the messaging, right? The same source port, destination ports, of course. We both need that. Port numbers. Okay, move on to the port numbers. We have the multiple separate communications with source port and data port. Destination port. Socket pairs have source port and destination port. All right, in the FTP request, BC close. Port 21 is web page using same layer 2, layer 3 addresses. This is port number 1099, and then this service on port 80. Okay, we have this is socket pairs which contains the IP address with the port number. Okay, which will tell us the socket pair. Okay, the socket pair. Okay, this one is one socket pair. We can see these two sockets combine to form a socket pair. Web port number groups, we have well-known ports from 0 to 1023, reserved for common public services. Well-known, okay, well-known, they're well-known. Ông chia phòng gì đấy? Cục luôn. Phải nói chơi bắn tỉa đéo có cung chơi chó gì. Bắn tỉa là cần 4 cái cung lận đó chứ. register ports. This port number is assigned by any to request entity you use with specific processes or applications. It's really a server authentication process. Okay. Because my battery is low, so I change it to make it performing better. Private and dynamic ports. Okay, ephemeral ports. Okay, we have this one, which is the port number, including. Okay, they're gonna be this 20 TCP from 2021 to 35. Okay, then domain name service, which is TCP, TCP port 53. Oh, we will have to remember all of this. HTTP for AT, POP3, post office protocol for 110. 143 is Internet Message Access IMAP. The SNMP is 161. 443 is the HTTPS. Client or server are 868 and 67. We have Telnet, Secure Cell, FTP data, FTP control. All right. Nestat command to show the active connections. You have to resolve the IP, which is and now here to the meanings of port numbers to well-known applications. When it's this port number in the numerical form, we're given to request service from a server which would display the correct socket pair. Once to request from this, a host with this IP address 10 to this 254.10 to the 254 server, so it could be this. Oh, port number is one on. All right. Firstly, is the IP address and the port number. Okay. They are all well-known ports in well-known ports. Foreign address is the Nestat. Protocols in use, the local address, port numbers, the foreign address, port connection state. Next. Oh, that's all. And then TCP communication process. Three-way shake. Client sending TCP request. Now we have here the clients. So we can see that client 1 web services and client 2 is with email service on the same server. And then request the destination port. Using well-known port 25. Request source port. Once send the material source port number. In this case, is using source port 49152. Okay, which is the source port. Individual dynamic port numbers are the source port. Response destination ports. Request packet as the destination port. And response source port. Okay, that's it. Wait a minute. Port group, we have known ports 1914915 49151 okay, it registered, and then from that to the 65535 looks like 10 power of 2 2 power of 10 plus 1, is it 2 power of, no, this is 10 and this is gonna be, I don't know, but like that. All right, we have the TCP connection establishment. We have SYN for SYN. Is available to communicate. Host B is available. Acknowledge and SYN. The three-way handshake. What it is if the host is available to communicate. Host is has been okay. A send to B and B receive this. B will send in acknowledgement. Once again, we have sequence 100 and control is in. And then it's sent as about the acknowledgement. And then also send the back to control, which is syn ACK acknowledgement. Then okay, they are received. Then it will acknowledgement this. It will turn the sequence number up to 101, and acknowledgement will be 301, which is for this sequence. And then control is moving to ACK from syn. All right. All right, we have some syn with from sequence 101, and then we get the control is still here, but this is buffing into another one, which is, can be like, for instance, 300. And then we will get the first acknowledgement and then move it here, and that will be up buff to 301, and this, there's the SEQ is to 101, which is added once. Okay, we have session termination, acknowledgement, the finish. Okay, finish. Send finish receipt. There's no more need to send the stream if sends a segment within the finished flag set. Okay. And then as once again, we will do this acknowledgement response and send request to A. All right, as you can see, this sequence is 300 from 101, and sequence is 200 from 101, and this will be 301. This to 101, and again 301 to 102, and then will be like this. Yeah, and finish. Send finish and finish received. Okay. So far so good. Next, the final step will again says acknowledgement, like this, but then with new one you can see before, and the session establishment, like this. We send back as we can see 101. Okay, ACK of 1. Okay, this is present on the network. This has active service is accepting request on this. Okay, and from okay this. Okay, oh, this is too much. Source port destination port sequence number acknowledgement number sequence acknowledgement at a link reserved control, which is 466 window for 16 if contain data is urgent 16 checksum for checking error 16 options, okay, or O or to if any, and then the application layer data side urgent acknowledgement flag push function resetting when error or timeout occurs. Synchronized sequence were used in connection establishment finishment and used in this. Okay. Next, we move on to. Oh, all right. Maybe we don't do this. We will move on to the TCP communication process. Host connecting to an email server. Email. Oh, I do not really know. Forgot this, but it should be a valid. It is for HTTP, right? With this. Okay, simple mail just for protocol. Should be from our register port to a well-known port. Which control bit flags are used? Oh, bit flags? Maybe fin reset. Really, as in or as in egg. Ah, yes, it's in egg. Okay, which is what we call bit flag here. All right, how many exchanges are needed to end both sessions between two hosts? 3 or 4? Sends a fin, sends an egg, and then sends a fin. Yeah, yes, we can see that. Actually, it's not really correct, but it's still okay. Too much thing to learn? Yes, sure, it's okay. What else to feel good with this? For exchanges, okay, send sends and fins and egg and fin, and then send egg once again. All right. Okay, reliability and flow control. Okay, we can move faster to this because it's like reliability. Data loss and transmission. If it's lost, it will send us back. Okay, we can see this. Duplicate segments. So it will take a long time. Oh, we have here egg freeze and then send this egg 5 to 10 once again. This does really not really matter. Every other factors beyond the scope of this onto this behavior. Okay. Window size and acknowledgements. We have sent window 10,000 megabytes bytes. So number 460, 461. Window size acknowledgement to 921, and then receivers once again. Size the number of bytes that destination device TCP session can accept and process at one time. PC initial Windows size is 10,000 bytes. First byte, the last byte PCA can send with the receiving acknowledgement is by 10,000. Okay, send window. Okay, this is also known as the send window PCA. Every TCP segment with the Windows as minimum of the buffer availability have been received before sending an acknowledgement. It could be that increments are from okay if the availability of the destination buffers decreases, window size to inform source reduce the number of bytes you should send when receiving an acknowledgement. Maximum segment size MSS. Okay. We have Ethernet IPv for the payload as well. Okay, all right. We have TCP, flow control, congestions, avoidance. Okay, you simplified for the illustration processes. We have used by the destination port is the real example is the source port or the destination port sequence number. Okay, used to provide flow control destination port. Ah, nah, window size. Okay. When sending host senses there is congestion, it will receive the number of it sends. So the signal will reduce the size and before receiving acknowledgement from the destination host. Okay. And that should work with our UDP communication. Low overhead versus the reliability. Does not establish a connection before sending data. To just like VoIP. Data is UDP connection less and unreliable. Different routers to destination are out of order. Okay, is out of order. And the datagrams will not be sent if it's lost. Listening for request, port 1A12. Okay, if sending a UDP request like this, Radius authentication service using register destination port 1912, for instance, and then request the source ports. Then it will send the destination port. Make make a response. And then this is gonna be the response of this. Which is really matter if it's like not really working. Desirable for make a simple request and it is low overhead. In order that it was received. which would be a valid source for host connecting to a DNS server source to a DNS. This one's not register is register port, so it's not correct. Okay, just layer summary. Okay, flow control. Application dependent for error correction, reliable sequence number, efficient delivery, less overhead. The transport layer. No, this was not correct. No, also not this. No, not this. Use port number this one. TCP is used. It have the length header, so it has the source port. It has the destination port. It does not have checksum. It has acknowledgement number. I don't think so. The window size, the length. All right. Acknowledgement number, now checksum. Now window size. Sequence number, of course, not checksum. No. Acknowledgement number, is it? Maybe sequence acknowledgement window size. Acknowledgement. Yes, I think. Window size. Most part use the window size, right? Quang ơi, tao bán mail nha Quang. Tôi cảm thấy mail không xài được rồi. Ồ, tôi cảm giác không không xài được. Mail thật sự không gánh được tôi đấy. Mail phế quá à. Ồ, gặp hóa chủ nữa chứ. Thua rồi. Cút rồi. Hóa chủ còn phải mạnh vậy ông trời. Ai ố xì ba à. Có liên quan là tôi cút về. Last segment send. Next segment sent complete determination or termination, or almost acknowledge from the server client. I forgot this. Such as this one is it TCP server process. Many ports open simultaneously to server application. A host into the application also configured. Network congestion will be resulted in the source learning and the loss of TCP segments. The presenter estimates one way addresses this. It will congestion, so it decreases the window size. Now the source, yeah, this one. What two features of protocol used within the TCP protocol stack? One. The essentials were used for all the tabs open the center within the browser. Or did you check responses to request? UDP is the sending device. It's not received from the destination system within a certain period of time. Maybe this one's correct. All right. Method of management segments of data loss is acknowledge retransmission before transmit. Received by sender sending transmitting more segments into a section. Acknowledgement size, missing segments of data, number of bytes. Oh, is this one acknowledgement window size used to identify missing segments of data. Wait a minute. Used to identify missing segments of data. Receive is for transmitting more segments into a section. Segments of data loss received by a sender. It should be acknowledgement here. Okay, this one. Connection oriented. TCP, connectionless UDP, acknowledgements TCP has a large header TCP, or delayed intolerant. What is delay intolerant mean? Is it we can use less effort delivery. UDP low overhead. Terminated TCP. Terminate. So it is finished acknowledgement. Oh, number 7. What is that? Oh my gosh. It is the control bits on window now reserved. This data is reserved or not on control bits. I just try to do this. All right. You're not past this, actually. Oh yeah. All right. Let's see what is here. Application dependent. So it cannot ever do error correction. Ah, yes, UDP. Length, source port, and checksum. Sense of segment with the theme flag set to 1. Client saying a thin flag to 1. Server says acknowledge to fin. To acknowledge the fin. Server says move fin flag to 1. And then the client responds with the final act to acknowledge the fin. A segment with a from client. 1 for each active server application. Then simultaneously on the server, 1 for each active server application. Host sharing as web server application and file just publication may have both configured. You cannot have both this. Use the same server port. So a host running to different application cannot have both. Okay, a host running to different applications cannot have both. Good. Okay, the source. Okay, this one's correct. A control base. Okay. 2 indicates the progress and the status the connection. Okay. Okay, both of this correct. All of this correct as well. Suitable for delay intolerant. We can delay this. All right. Delay. Okay, good. And then we do this. All right. We have. Okay, I think we can pass it. I think so. All right. Just port layer quiz. Kinda numerous things to do. Still need 29 and 32. Okay, fighting. Reliable TCP. Sequence number, efficient delivery, less overhead, UDP. Okay, both use port numbers. Use DP segment header, we have source port, we have checksum, we have length. Of course, both source port and length are on the same move on UDP and TCP. A segment with a SYN flag, not a ACK flag set to 1 from the client. Okay, next we can have both configured. They cannot have both configured. Simple right within the same transport layer. No, not this one, because cannot have 2 services assigned, and like this cannot both configure, and this also not both assigned. The destination, the source will decreases the amount of data that it transmits before it receives the acknowledgement from destination. Well, in the case of the status, the control bits, Checksum is for checking correction. Window is for the maximum size. Next, TCP/IP protocol. Okay. Managing segments data loss. Retransmission. Missing segments of data. Connection-oriented, connectionless. Has a large header used to go for delayed intolerant effort delivery. Low overhead. Okay, finally, fin and egg, which is for termination. Okay, ARPD and SDHCP. I mean, like we'll do this one first and later we'll do this later, but I need to do all of the lesson plan here. We have 29, all of 29 and 32. Internet Control Message Protocol ICMPs. Host reachability, destination service unreachable. Time exceeded. Host reachability. No, sends an CMPA call request to a host available. Okay. Net unreachable, host unreachable, protocol unreachable, and the port unreachable. Okay. Net, host, protocol, and port. Okay, with no route to destination is administratively prohibited. Address unreachable, port unreachable will be the last one. Every time port unreachable will be the last one. And address unreachable beyond scope of source. The firewall is one, not unreachable is no route to destination. These look like the same things. We have beyond scope, beyond. Okay, next move on to the time exceeded. Was decremented to zero. Okay, we have time exceeded, which is message we is used by router gonna be forwarded because time to live was decremented to zero. Are used by the trace route tool. Okay, messages we have the solicitation RS and the advertisement RA. Neighbor okay, with also the neighbor, which is for IPv6. Duplicate address detection and address resolution is an address dynamic address resolution. Okay, that's right. Route solicitation. Mhm. Every 200 seconds. RA can include addressing information for hosts, such as the prefix length, DNS address, domain name, stateless address, auto configuration, stateless address auto configuration. R1 sends an RA message. Hi, OA is. Okay, as your default gateway. This looks nice, cute, I think. Solicitation. The advertisement as solicitation. R1 replies to RS with an RA message. RS message is the IPv6 router on the network. Need to know how to get married information dynamically, and then R1 router 1 is no RA message. So we send a solicitation message, and then we will the response the advertisement message. So far so good. Next, which is the neighbor solicitation. Okay, that is not the ID is not required. This the ID is performed on unicast addresses. Okay, how one sends an address social and else message. Whoever has to be blah, 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 send me your MAC address. Reply with the NA message. Okay, okay, sure. So if we will, the router will ask with our who got this IP address, show me your MAC address, and then we will send them again our, hey, I am this one, and I will give you my MAC address. Okay. Internet Central Messages Protocol, common to both. Okay, we have destination or service reachable, unreachable. We have no. I think reason is for the HCP source no, and time exceeded, which is time to leave. When it's decremented to 0. When booting up, would a host send? So we always like the host centers are an S, and we just get them an A. Router booting up. Router solicitation message, and the router will respond with an advertisement. Okay, so we send them a router. Okay, good. Next, ping and trace route testing. ARP on ND needs to be formed before sending the ICMP echo request. Ping a local loopback, the default gateway or the remote host. Okay, ping a loopback. Mhm. Network layer. This response is not an indication that the addresses, masks, or gateways are properly configured, nor there is indicate anything about the status of the lower layer of the network stack. They simply test IP route through the network of the IPE and then indicate that TCP is operational on the host. Okay. Ping the default gateway. Mm, Ping the default gateway ICMP echo request. Send to it seems like doesn't really matter if it like this. Echo request, and then the router will send us back a echo reply. Remote host. Limits the prohibited ICMP messages in the corporate network that fall like Hop limits, round trip time. TTL, like it will be decrement by one every time it moves in make a hop. Interference reached. Okay, and finally, what's the reflection questions in the quiz? To ping is to check the connectivity between the PC with the default gateway is on the loopback, right? Loopback. What is the ping loopback to? From the local host? A call request, trace route, right? Like figured this respect to remember when the packet has expired. Hop limit or time exceeded. My finger is no time exceeded field. To source code about errors. Rather to restrain them, usually unlessly on the network. In decrement to the idea of the one if there's a zero, it's gotta be consistent time exceeded. Take me to the light, into the dark side. Let's feel it, let's change it. What will used to be connected to network host? ICMP. Ah, ping. Ping is not trace route a remote service, which is which is in the path to the destination. Never stop forwarding the packet. When our value reaches zero, receives an IP CC type message. Echo request reach zero. Alright. Which is in the path to stop for trace route. ICMP send and receive echo requests and record replies. Host to check the uniqueness of it. Okay, is host. Again, the host is solely. Wait a minute. Just want to check it once again. We have this one. So our PC send we will client will send our message. And then if we send RA message, the host will send RA and the NS, but to check if it's gonna be it's kind of cold here. Oh God, kind of cold up here. So we show us the RA ask us who is going to have this IP address. Provides network address information to host the user. Two, it one is network unreachable, and then host unreachable, and then protocol. I think so. That one is always support. Oh, stack on. Just maybe stack on that. We have a bit of 2 days. Thank you so much for being here.